Hello dear students. So in this last chapter or the earlier chapter we discussed about various sources of radiation, and now in this particular chapter I'm going to deal with the theory of radioactivity, that is basically the formulation or the mathematical formulation of radioactivity. And then in the last subunit of this chapter, we are going to do some numerical problems related to the theory or the mathematical formulation of radioactivity. So in this particular subunit, I'm going to give you an introduction to radioactivity as a phenomena, and I'm going to start with the discovery of radioactivity. So how was radioactivity discovered? So most of the nuclei that we know are basically stable. So they do not disintegrate into lighter nuclei and they remain stable for an indefinite period of time. However, there are certain nuclei which disintegrate and they are called as unstable nuclei, and they disintegrate spontaneously. The phenomena of spontaneous transformation of nucleus is known as radioactivity. And it was Henry Becquerel in 1869 who discovered this phenomena. He is a French physicist who was working in the field of fluorescence, and he found out a new type of radiation coming out of certain types of materials, and in 1869 he was the first one to discover this phenomena. Now radioactivity is an accidental phenomena. Actually what happened was, in 1895 X-rays was discovered by Röntgen. After the discovery, a French mathematician, Henri Poincaré, who was extremely interested to find out what is happening to this particular phenomena, so he gave a talk on X-rays in Paris, and he suggested that the X-rays are basically some kind of fluorescence of the glass of the Crookes tube, in which cathode rays or the electrons are produced at low pressure. That is, in a Crookes tube, in a very low pressure, in a vacuum-like situation, when cathode rays are present and when they strike the glass, they produces a fluorescence kind of phenomena, and those X-rays are basically result of that particular phenomenon. But Becquerel was a specialist on radioactivity, so he decided to check this idea. So he decided to perform experiments on fluorescent materials he had possessed, and the fluorescent materials that he was using was potassium uranyl sulfate, which was a salt of uranium. So during his experimentation, he found that this idea is wrong. What is happening is, it is not the cathode rays which are producing fluorescence, but something else is happening in the Crookes tube. So once he had a sample of potassium uranyl sulfate, and he had a photographic plate wrapped in thick black paper under the sun. So he just kept that salt over a photographic plate which was wrapped in a thick black paper, and he thought that fluorescence effect would take place, but what he found was not what he was expecting. The rays which were coming out from uranyl sulfate or the potassium salt, the uranium salt, that particular rays were able to penetrate the black paper. So those rays, the black paper was not opaque to those rays. So those rays were able to cross that particular black paper, and they were able to create an impression on the photographic plate. But then once there was the weather was cloudy, so on 26th and 27th of February he found the weather is cloudy, so he kept this salt, which was in the same position, kept over a photographic plate which was wrapped with a black thick paper, and he kept it in a dark drawer in his lab. So when he developed those photographic plates on March 1, 1896, he found that an impression was created of very high intensity. So even without any sun rays which are required for any fluorescence phenomena, what was happening without sun rays, that particular salt was emitting rays, and those rays were coming out and they were passing through the opaque black thick paper, and they are creating an impression on the photographic plate. So he was surprised, what kind of rays are these? They are not basically fluorescence rays, but are something different. So here, this is the original photograph that you can see of the impression of the salt or the material or the sample that was kept on the photographic plate. So the impression created by that salt, which was emitting some unique mysterious rays, that impression that was created when that salt was kept in a dark drawer is shown here in this original form. So once it was discovered that some different rays are produced, different scientists from France as well as from Britain were attracted to this phenomena. Pierre and Marie Curie in France and Rutherford in England were quite interested to study this phenomena. Becquerel himself created a gold foil electroscope to study this phenomena, but he never used the electric method. Electric method would have allowed a more quantitative measurement, but he only used a gold foil electroscope, and he found out that these rays are going to affect the gold foil electroscope. But electric methods were different. Basically, in electric method, what was happening was those rays that were coming out, they were subjected to electric and magnetic field. And then what was found was that those rays are affected by electric and magnetic field. So further studies showed that electric and magnetic field deflect these rays. So these rays are basically charged rays and not light, as in the case of fluorescence, or not even X-rays. So they not only affect the photographic plate, they ionize gases. So basically when they're passing through a gas, they ionize that gas. They make that gas charged, and they have a penetrating power. Even through the solid materials, they can cross those solid materials and they can penetrate deep inside those solid materials. So here what is shown is that you have a radioactive source which is kept in a lead container. So lead container blocks almost all of radioactivity, but there is a hole in this lead container through which radiation is passing, and then you apply an electric field, that is two plates, one with a positive charge and another plate with a negative charge, which is producing an electric field in the vertical direction. And what they found, some of the rays are deflected towards the negative plate, some of the rays are deflected towards the positive plates, and some rays go undeflected. So these are the three types of basic rays that come out, and the differentiation between these rays can be seen by applying an electric field. The rays which are attracted towards the positive plate are called the beta rays, and the rays which are attracted towards the negative plate are called alpha rays, and gamma rays are the rays which are basically going undeflected.